We're live.
All right, amazing. Thanks for joining, everyone. Welcome to another workshop as part of the Dora Hacks Hackathon that we're running in behalf of the foundation and Who Will Be Incubator. So my name is Alberto. I work at developer relations at Moonbeam, and I'm joined today by Scott and James from SubQuery. And we're going to do like a joint workshop. And then first, I'm going to talk a little bit about XCM on Moonbeam. And then Scott, I think mainly Scott and James as well, is going to do a little bit of a presentation of how you can leverage SubQuery to help around with this XCM-related bounties that we have for the Dora Hacks Hackathon. So one introduction on XCM is that this is a very, very new sort of technology that it's very like on the bleeding edge of Polkadot and Kusama. And one fun story is that it's not something that you can just Google like how to do an XCM message and just like it's quite complicated, right? So Scott, James, and I met on Tuesday, and we're like, this is going to be complicated because it's not something that it's easy, right? And you'll see when I go through the workshop. If you don't know SubQuery, they're an indexing solution for substrate-based blockchains, and the indexers are key in any blockchain that you've heard of because they provide a way to in a very efficient way store data in very efficient like databases from events or extrinsics, so you can access it in a more efficient way, right? So like I said, I'm going to start with introduction on XCM, and then I'll hand the ball to them so they can talk about SubQuery and how you can leverage in this XCM project. So with that, let me share the screen and we can start. We have these slides. I'm going to share them at the end of the presentation, but we have these slides. We can share them with you so you can check it out after the presentation. So XCM. So what is XCM in a technical introduction? If you know how Polkadot is in its architecture, right? The idea of Polkadot is that there are these blockchains are called parachains that connect to it, and Polkadot or Kusama are like a central hub. And so the idea is that these blockchains and this whole ecosystem can communicate with each other, and they do it via XCMs. XCM stands for cross-consensus messaging, or it's also called cross-chain messaging. So XCM is a format and not a protocol, right? I like to explain it as, do you guys know how you write emails, right? When you write emails, you have sort of these like rules where you like have an introduction, you have the body, you have like the outro line, and then the signature. XCM is sort of like that, right? It's a format of how two blockchains can communicate with each other. So it is very generic. The idea is that it is not tangled or chained to specific rules. So the idea is to be as generic as possible. And there are certain like actions or things that people can do with XCM. And so there are many strategies to do XCM. You can do it between parachain and parachain and relay chain. And there are different strategies to do it. For example, token transfers. You can also do remote calls and other blockchains and so on. If you want to read a little bit more about XCM, I definitely recommend you to check the Polkadot wiki. There's a ton of information there that will go into a lot more detail than I'm able to do here in this 1 hour presentation. So definitely go check that out. The transport protocol is how the XCM is passed around. I mentioned before that XCM is the message itself, but I've not told you how the message goes to point A to point B. In the context of Polkadot or Kusama, this is done via three main transport protocols. The first one is called VMP, or vertical message passing. And this is terms that you will see later on when we start looking at a live demo. When the parachain, in this case Moonbeam, communicates with the relay chain, so the parachain being the origin, it is called an upward message, okay? And then when the relay chain communicates with the parachain, so Polkadot sends a message to Moonbeam, it is called downward message or downward message passing. When two parachains are going to communicate with each other, or they're going to talk with each other, there's actually something called XCMP, or cross-consensus message passing. However, this is still being implemented, and as a stopgap protocol, you have HRMP, which is horizontal relay routed message passing, Honestly, I don't know who comes up with these names, but that's how they name them. And the main difference with horizontal relay routed message passing is that it actually goes through the relay chain. In this case, goes through Polkadot, and then the Polkadot relays the message to the other parachain. In the case of XCMP, only the relay chain only stores a hash of the message. So XCMP is expected to be more performant, but in the meantime, all we have is HRMP. By the way, you have the Ask a Question button. You feel free to ask a question anytime, and I'll try to get to it whenever I can. So the first use case, or the most common use case for XCM is transferring assets, right? This is already live on Moonriver, Kusama, Moonriver, and other parachains. And basically, there are two main ways of moving assets from one place to another. The first one is via teleporting, and teleporting is similar to like a burnt mint mechanism on any Ethereum. If you're familiar with Ethereum EVM bridges, it's similar to a burn mint mechanism, where you actually, let's say you're transferring tokens from Polkadot to Moonbeam, you will actually burn these tokens so they no longer exist on Polkadot, and you would mint. Actually, you will check that the tokens were burned, and you will mint some new dots and transfer them to the target destination. In the case of remote transfers, what you actually do is similar to like a lock, mint, burn, and unlock mechanism. So this is how a lot of EVM bridges work, where you actually lock the tokens on one side on a smart contract, and then you mint on the other side as a wrapped representation, right? If you want to come back through the bridge, what happens is that you burn the wrapped representation, and then you unlock the tokens on the smart contract. This is very similar how it works in Polkadot. Let's say you want to transfer some dots from Polkadot to Moonbeam. What happens is that these tokens are transferred to a special type of account called sovereign account, and I'll explain it on the next slide. And basically, Moonbeam will check that these dots are held actually in the Moonbeam sovereign account, and it will mint a wrap representation, and that's why here there's a different color, because this is a wrap representation of these dots, and these are sent to the destination account. Okay. So this is the difference, right? And basically, with all the parachains, remote transfers are where actually it's being done, because in asset teleporting, you need to trust that the parachain is not going to mint more tokens than what the relay chain burned. So because there's this inherent trust that needs to happen in teleporting, basically all the parachains work with remote transfer except StateMine, but that's a minor, minor parachain in the case of implementations. So the sovereign account is this element that I showed right here in this diagram, and it's basically an account that is owned by the parachain. It is not owned by a single person, right? And its main usefulness is to hold the accounts or hold the funds that are being sent. So it's similar to locking smart contracts on Ethereum bridges, right? Instead of locking it on a smart contract, that the funds are being held by the sovereign account, which is controlled by the whole parachain. So this is either pseudo, if the parachain has pseudo, which is not the case for Moonbeam and Moonriver, or democracy, right? So you can actually control these funds via a democracy vote. And the address of these sovereign accounts are deterministic. And it is actually, you can actually calculate them with this example code that I showed on the right-hand side with the parachain ID. The parachain ID is sort of like a unique identifier of a parachain in the whole Polkadot ecosystem or the whole Kusama ecosystem. In the case of Moonriver, for example, is 2023. And so how you can calculate the sovereign account, if this is important in the case that you need it, I linked a GitHub, basically a code in my GitHub profile where you can actually run it with the type TS node, where you use the calculate sovereign address .ts file, and you pass in the pair ID of the parachain that you want to calculate the sovereign account. In the case of Moonbase Alpha, which is our testnet, the parachain ID is 1000, and you can see the different sovereign accounts either on the relay chain, on other parachains, or on Moonbase Alpha itself. So these are just some example instructions of XCM, right? XCM as it itself contains XCM instructions, and these can be like withdraw an asset, transfer an asset, by execution, which is basically used to allocate some resources to transact on another parachain or blockchain. And they're just different representation of instructions that I just wanted to show you, so you're familiar with them whenever you see an XCM. And each XCM instruction has a weight cost. So it's similar to gas on Ethereum. Like each opcode has a gas associated to it. In this case, each XCM instruction has a weight cost. So in the case of Moonbase Alpha, it's 100 million weight units per instructions. So for example, a simple token transfer on XCM actually uses 4 XCM instructions, meaning that you need to provide at least 400 million units of weight. And I added some GitHub links of where you can find this information. This is different for any parachain, so you would have to check how much you're actually charging per XCM execution in terms of weight. This is just, for example, an example of a different XCM message. You can see this XCM message has 5 instructions. So the first one is to withdraw an asset of the sovereign account in this case. Then we're going to buy some execution time in the destination blockchain. Then we're going to transact. We're going to actually do something with that execution, and we're going to refund some money that it was not used after the execution is run. And then we're going to deposit that money into an address. So the idea of remote execution is that you can actually execute a series of instructions in another chain. And this is truly powerful because what we see happening in the future is that other parachains can access the Moonbeam basically EVM through a remote contract call. And we think this is going to unlock a lot of stuff, and it's going to be really powerful when this happens in the near future and when this is activated on Moonbeam. We have received a lot of interest from other parachain projects about this sort of scenarios. So yeah, this is something that's still not possible, but we expect this to happen hopefully this year. So Moonbeam and XCM. So if you're familiar with Moonbeam and Moonriver, you know that we're always trying to find sort of like an Ethereum twist to everything, right? So that way developers can access features that are not Ethereum native through the Ethereum API. And so for XCM, we did something similar, right? So for example, one example of this is the introduction of XC20s. If you're not familiar with what XC20s is, it's basically our Ethereum-compatible solution for these assets that are natively interoperable. So if you think about, for example, a mover or car from Karura or BNC from Bifrost, when they actually move these assets to Moonriver, they actually are what it's called substrate assets. So you cannot really access them from the EVM because they live outside of the EVM. So what we've done is to create a way that you can access these assets via an ERC20 interface, as you see here in this diagram. The really cool thing about this is that from an EVM perspective, you can actually interact with these assets with tools such as Hardhat, Truffle, Web3 JavaScript, Ether.js, and you can actually add them to DEXs. I'm going to show you guys in an Uniswap v2 clone that we have in our testnet for demo purposes only. We actually added some of these assets so you can actually get them for the bounty if you're going to do the XCM bounty. And on Moonriver, we have seen these assets being listed on DEXs, on lending platforms, because that's the power that XC20 tokens have is that they're actually substrate assets that are fully interoperable with other parachains in the ecosystem. But actually, you can access it like a regular ERC20 interface with the transfer functions, approve functions. You have the read methods like balance off, et cetera, et cetera. So that is actually one of the Ethereum twists that we did for XCMs. And then we have another one that I'm not going to present today because it's not relevant, but I'm actually working on some documentation for it, and it's going to be soon in our documentation site. So, there's actually a question. Cool. Oh yeah, that's actually a very, very cool question. Oh, Zoombies, is this Ryan or Jesse? I'm not sure, but anyways, yeah. So I think they will probably be. We're still actually thinking how the NFTs world is gonna work, right? With XCM. It's Ryan. There you go. So yeah, like we discussed yesterday, the idea of NFTs is still being explored. We're like at the sorry, yeah, good point, Chris. So the question from Ryan was, will there be an XC721? right? So now that we have XC20s representing ERC20s, will we have like XC721s representing ERC721s, which is one of the most common standards for NFTs, right? So I don't want to shoot myself in the foot saying that there will be an XC721, but as always, we always look for ways to offering an Ethereum compatibility solution to these sort of problems. So I don't see why not. But we have to fully understand what is the meaning of having an XC721 and how like projects will use them. And we're probably going to need your help for that. So I'm actually glad that you asked that question. So what I want to do now is show you a little bit of an XCM message, right? So I'm actually going to go ahead to Polkadot.js apps, and I'm going to show you a message from, for example, Moonbeam to the relay chain, from Moonbase Alpha to the relay chain, right? And just so you're familiar a little bit with what it means to send an XCM message from Moonbase Alpha to the relay chain, right? So what I'm going to do is I'm going to head to Moonbase Alpha. Go. And basically what I'm going to do is that I'm going to try to submit, I'm going to show you how to submit sort of like a XCM message, but we're not going to submit it. I just want to show you how we can actually leverage XCM in this sort of situations. And in the meantime, I'm also going to load the relay chain of this testnet. All right. Yeah, usually it takes a little bit of time to load the. All right, let me put this here. So in here, this is Polkadot.js, and basically what I'm going to show you guys is that you can go ahead and, wow, this is really slow. I'm going to go to extrinsics, and I'm going to actually decode the call data that I put here as an example, right? So you can do the same later on so you understand this example a little bit, at your own rhythm. So this is basically what an XCM message looks like. And let me zoom in quite a bit. So we're using the X token palette to send these this XCM message. So we're going to transfer some assets. And this is how you represent an asset on XCM. This is called multi-locations. So the idea here is that a multi-location is a point in the Polkadot or Kusama ecosystem. So in this case, because we're standing on Moonbase Alpha, we want to try to find the relay chain asset. In this case, it's called units. And so basically, we have to say parents one because parents is like a hop that you go if you want to pass through the relay chain. And then the interior is called here because this is how the relay chain sees its own asset. And I know that it's confusing, but we have also another workshop that I did that I put it in the slides so you can understand a little bit more about multi-locations. But you can see that basically this is the way that Kusama sees its own asset basically. By using parents one, this means that you're going through the relay chain and then interior here. Every other parachain actually represents or sees its own asset in a different way. It could be interior and have two fields represented. It could have one. And then you will see a lot more examples in our documentation side or actually in this workshop as well. Multi-locations can also be used to define a destination in this case. So once again, we want to transfer to an account on the relay chain. So what I'm doing here is saying parents one because I'm actually want to hop one step into the relay chain. And then I'm saying I want to have a field to define a relay chain account. All right, and this is a relay chain account that I'm transferring these tokens to. So I understand this is a little bit, a lot of information, but I don't want to focus on this because I want to focus on some information that we have for the bounty. So I did actually add a link to the workshop that we did on XCM. I think it was like 2 or 3 weeks ago. And that goes into a little bit more, actually like a month ago. That goes into a little bit more detail on XCM and how to build an XCM message and so on. And you can also find these encoded call data here if you want to try it yourself. So because we're going to talk with SubQuery and we have James and Scott here, one of the things that I thought it was interesting was to talk about the related extrinsics and events, because they're probably going to explain it way better than me. But SubQuery actually indexes information based on extrinsics and events. So if you're going to start indexing XCM information, you should know or you should have the actual extrinsics and events that you want to look into, right? And so I started with the XCM related extrinsics. Why? One important thing is that actually I'm going to leave this like here because I'm going to click on these links. So one of the things that is really important is that it really depends on the chains that are interacting. So in the case of, for example, Moonriver, Karura, Bifrost, we all use a palette called X tokens. So you're going to see, for example, extrinsics that are start with X tokens. So let's say that you're transferring from Moonriver to Kusama. On the parachain, you will see an X token extrinsic called transfer multi-assets. And this is actually, it contains the XCM message itself. And there's actually no hash associated to this message. And this is actually one of the problems that we still have. And that's why I put a warning sign here. On the relay chain, you will see an extrinsic called para-inherent, which actually has a lot of stuff. And I'm going to show you what it has. And then if you go one block up, you will see another extrinsic or another event related called UMP upward message received with the parachain ID. So this is actually part of the event and part of the extrinsics that are associated to it. So if I click on this link, this is going to take me to Polkadot.js, to a block that I did an XCM for this workshop. And you will see here on the, if you actually look for X tokens, you will see that the extrinsic that was initiated was an Ethereum transact. It was because this was done through our Ethereum API. But you can see that the events associated to this is actually an X tokens transferred and so on, okay? But it just really depends on how you're initiating this XCM message. If we go to the relay chain, I'm going to go to the relay chain block, this one right here. And you're going to see that the extrinsic is called para-inherent enter. And this is pretty crazy. It has tons and tons of information. And a good strategy is to look for the Moonriver's parachain ID, which is 2023. And you will see basically down here, you will see upward message, right? Like I said before, a message from the parachain to the relay chain goes via an upward message. And this is actually the upward message that you get, okay? And I'm going to show you a tool that you can use to actually decode this message. So I added a lot of these examples so you guys can take a look at it. You know, you have a related extrinsic from a relay chain to the parachain. You have a related extrinsic from a parachain to a parachain, and some links with examples on Polkadot.js that you can look into. So actually, I finished coding this with Gorka, with another friend from a colleague from Moonbeam this morning, basically, and it's a couple of codes of TypeScript code that it's going to help you to decode this XCM message. So basically, it's going to help you to decode this bunch of bytes, and this is useful because you're going to be able to see on the relay chain, on the target destination, on the target blockchain, what is actually the content of the message. Because imagine that you get 5 upward messages. You have to understand, you have to know, okay, so this message that I'm reading right here, it's coming from which parachain. And this is actually a problem because we have no hash on the origin chain, right? So the idea here is that you can use these two commands. One is to decode the upward message sent from a parachain, and this actually provides, you have to provide the WebSocket endpoint, the block, and the parachain ID. And I provided here an example that you can run on your own terminal, and you actually will see this code working. We also printed as well the hash of the message, and you will see that the hash of the message actually shows up in the destination blockchain. You can also find another code that is to decode messages that are either downwards, so relay chain to parachain, or horizontal, meaning parachain to parachain, right? And once again, these are the inputs that you have to provide. And I also get left here an example of how you can run this code. And just as an example, these are a little bit pixelated, but you can see here that when I run yarn and to decode the message on the relay chain, so this is the message, the upward message that was received by the relay chain, you can see that the code calculates the hash, the Blake2 hash of the message. And these are some of the instructions, XCM instructions that this message actually contains. So you can see some of them that we actually mentioned before in the presentation. And you can actually start looking more into it. If you want to go into the ID, you want to go into the fungible part of it, you want to go into the interior of the multi-location, you can start exploring this, modifying the code that we shared. If you run the other one, the one to decode messages that are received by the parachain, once again, you can see here this as an example. This calculates the Blake to hash of the message. And then once again, it shows all the different instructions that are basically, related to this message. So you can see here that, this is transferring the tokens to an account key 20, which is an Ethereum account. It has basically the multi-location of the asset, its parents one, and then some interior that we have to find. But yeah, the idea is these codes will help you get started on the bounty. And, you have to expand on these codes for sure. So the related events, which is also very important and very useful, are actually, once again, similar to the ones that I put before, because there's no real extrinsic related to that. Unluckily, there is no message hash on the parachain, but there's actually a message hash on the relay chain. I'm going to try to work on the code that I shared before to actually try to calculate the hash on the parachain, which will be really useful if you're doing the XCM Explorer and you want to link one message on the parachain to another message on the relay chain. The hash will be key for this. Another events that are really important when you send something from the relay chain to the parachain, this is the attempted message, but there's actually nothing shown in this event. This is terrible. But then you have some other events on the parachain, and one of them actually has the hash of the event of the message itself. Once again, I left some links to the examples if you want to check them out at Polkadot.js. And you have, once again, a similar thing for a parachain to a parachain, where you have, the events in the origin parachain. This actually has the asset, the hash of the message. And then down here, you have on the target parachain also the message hash. So from parachain to parachain, you will actually find it really easy to correlate one message from an origin parachain going outwards to an incoming message on the target parachain, because you can actually link the two hashes. This actually makes your job a lot easier. So yeah, how you can get it started, right? To get it started, I would say that definitely you have to go to the faucet. We have a dev faucet. Dev is our testnet token. You can find the link here in the slide, how you can get started there. And if you want to get some XC20s to start playing around, we actually did something really cool that we have in our Moonbeam Uniswap v2 fork that is only for demo purposes. We actually have this here that I created liquidity pool, so you can actually get some tokens, right? So if you have some dev tokens, which you can get from the faucet, and you want to have some XCBNC to send an XCM message from Bifrost to Moonbase Alpha, you can actually get some, using this Uniswap v2 demo. And this is possible because of the XC20. So this is actually one of the really cool use cases that XC20 has. So it's actually an asset from Bifrost that exists on Moonbase Alpha, our testnet, and actually you can swap it here. This has no monetary value or anything. It's only for demo purposes. So with that in mind, I know this was a lot of information, but at the end of the presentation, we have some Telegram channels and Discord channels that you can check out and ask any questions that you have. Think that XCM is this very bleeding edge. So for us, it's not easy actually to put all these together, all this GitHub code. We just finished this up this morning because there's like no documentation on this. It is really, really hard to work around XCM. And we've been like experimenting with XCM for 3 months, and we're still like learning every day that this happens. I said before, I was telling Scott and James that this workshop is going to be a little bit crazy because a lot of the stuff we're actually learning as we go. So yeah. With that, I'd like to thank you for your attention. I'm going to introduce now, I'm going to pass the ball to James, which is going to talk about SubQuery and how you can get started working with them.
Yeah, thanks, Alberto. And as you say, right, this is all new. This is not something you can Google. So it's a huge opportunity for people that do the XCM grants, is that you're kind of the first one building these tools out there, right? And generally when you're the first one building good tools, those tools become adopted by the whole ecosystem. So this is a pretty unique opportunity for people doing the grant to make a big mark in the ecosystem.
Yeah, especially. One of the things, sorry that I interrupted, one of the things that why we decided to do this grant and to offer this grant is because XCM is still very new, and there's no like explorer around this, right? I mean, it is really something that when people do XCM and they ask me like, "Hey Alberto, how can I know if my XCM was executing?" I was like, honestly, it's a nightmare, right? So that's why we started discussing, James and Scott. It's like we have to do something that we have to do a bounty where people build an XCM Explorer that people are able to see a little bit more clearly or easily XCM stuff. So yeah, all right, thank you.
So I'm going to do a very quick introduction to SubQuery, and then I'm going to hand off to my colleague Scott, who's our senior blockchain developer and a lot more knowledgeable about XCM than I am. So I'll try to keep this very brief. Introduce SubQuery for those that don't know what SubQuery is. SubQuery's goal is really about making decentralized data more accessible. And what that means is helping take on-chain Moonbeam or Moonriver data and getting that into a format that you can use in your applications in a XCM Explorer, for example. So the main problem that we solve really is the query part, right? Blockchain data is in a terrible format to query. And in order to build increasingly complex and intuitive applications, like a cross-chain messaging Explorer, developers need more powerful tools to process and query that data in a faster way. So, for example, if you wanted to get a list of all the transactions in Moonriver, going through each block sequentially will take days to get that information. SubQuery will give that to you in milliseconds. So SubQuery is an open source project that allows developers to index, transform, and query Substrate or Moonbeam data to power the applications. We have kind of 4 components. The first is that you extract the data from a specific chain, in this case Moonriver, but any parachain in Polkadot, which means you can extract those XCM messages from any chain. You transform that data based on the rules that you set. You persist it or save that in a database, and then you can query that using GraphQL. And Scott will walk through this whole process later on. So we're the leading data indexer in Polkadot. We're open, it's open source. You can adjust SubQuery how you want. You can change it. Our code is publicly hosted, and many of our customers do change it. It's flexible. You define in your SubQuery project, it's like a scaffold in a way. You define the shape of the data that you want, and you define exactly where you want that data from. So it's completely flexible for your own use case, and you can use it in a way that you need it. You don't have to take data that someone else has collected. You don't have to change your application to suit some other data set. And finally, it's fast. We do a lot of work on improving the indexing speed. It's one of our main priorities. And so we make it as fast and reliable as possible that we can index data from Moonbeam or Moonriver and get that to you efficiently and effectively. So basic concepts of a SubQuery project. There are, actually, should I hand it over to you, Scott, here? This is kind of getting into the dev side.
Yeah, now's probably a good time, because I'm probably going to end up repeating a bunch of stuff otherwise. Maybe it's best if I share my screen. Okay, can you guys see my screen? Cool. So what I have in front of me is a SubQuery project that I've created a little while ago. It's just kind of a simple demo with a little bit of context towards XCM, and it's a rough starting point if you wanted to do the bounty. So this file I have here is a project YAML for SubQuery, and this defines your project. This defines what network you're going to use, kind of what data you want to collect from the chain, kind of where you start on the chain, everything you need to kind of pick and choose what data you want from the chain. So yeah, you have your kind of network information. So in this case, we have Moonriver. It's the same or like similar for Moonbase Alpha or Moonbeam. And then you choose your start block. So in this case, I've just chosen a block with some example data. But yeah, you can start right back at the beginning, or kind of when kind of features become available on chains as things get upgraded. And then I define my handlers. So I guess this is the key part. So here I have an event handler. So kind of covering like this is where you would choose the events or extrinsics that Alberto kind of has been over. So in this case, I just have one for X tokens transferred events. I guess this is kind of just a simple example, but you would have multiple of these. So he did the multi-asset transferred, and there's a few others. And on top of that, you can do call handlers or extrinsic handlers. And in the same way, you can filter them. So you can filter for specific extrinsic. So obviously, extrinsics related to XCM messaging and all those kind of cross-chain messages or upstream messages. So once you've defined kind of what data you want to collect from the chain, you then want to go to the other end and decide, hey, this is the output that I want. So you define your GraphQL schema. And in this case, I've just got a simple XCM transfer. So ID, just an ID for this entity, kind of who's sending it and where to. The parachain ID, so this will be the ID of the parachain that it's been sent to in this case, and the currency ID. So everything has an ID internally. So all the XC assets have their own ID that is kind of common across the whole parachain network, and then the amount of the asset sent. So I've gone from wanting this X tokens transferred event, and I want to map it to kind of this object here. And then so what I want is to define like a mapping handler. So every time that there's this specific X tokens event, I want to handle that. So I can take this event data, and I can take what I need out of it, and I can format it in the data format that I want. This is where you would use kind of the work Alberto's done and kind of in decoding that data. So there's obviously a lot more involved in kind of getting something working in a usable state, but this is just a simple example. And then kind of here I have like just a commented out kind of example of a call handler, where you get an extrinsic rather than you get a substrate event. So
Scott, I have a question, if you don't mind, now that we're here. The cool thing about this as well is that you can do like calculations. You can do a lot of stuff on top of this, right? So you can store whatever data that you want to handle. So for example, in the code that I shared, when we decode the XCM message, you can even like calculate the hash of the XCM message and store it here as well, right?
Yeah, this is a great place to kind of compute any data you want to persist, so that you don't need to keep calculating this. So like whatever consumes this data doesn't need to do a lot of processing on this data. This data is already processed in the format you need. Yeah, my example obviously doesn't have anything too complex in it, but yeah.
We could use the XCM decode para tool that Alberto has published in this to get information.
Yeah, exactly.
So that's actually how you would add these two workshops that we put together in a very sort of like a rushed way, because this is all very new and we're learning by the minute. So yeah. Ryan actually had a good question, and I assuming once again it's you, Ryan, and you're like switching the account. But anyways, the parachain ID, the currency ID that is shown here on the slide on 14, is it automatically assigned by the network, human, or who, right? And that's a question, I guess, for me, because I'm not sure if Scott or James have any clue about this. But basically the currency ID, it also really depends, Ryan, on how every network sees its own token, right? So for example, let me try to think about an example right now. I think, for example, Calamari, when we're doing XCM testing with them, they would use currency ID, like they would actually register the currencies in the runtime, and they would assign like an array index to each currency. So 0 being the Calamari token, for example, currency 1, ID 1 being Moonbase Alpha Dev, and so on. In our case, for example, in Moonriver, the currency ID are like two different things. You can put something called self-reserved, which is basically the native token mover. And then you could also put like other reserve or foreign reserve, I don't remember, where you will actually grab the network, the asset ID. So each XC20 token that we create on Moonriver basically has an asset ID associated to it. And that asset ID is calculated from the multi-location. So remember that the multi-location is a way to find a target, find something in the Polkadot or Kusama ecosystem. You can find an account, you can find a parachain with the parachain ID, or you can also find the token. The token being, I want to go to Moonriver and I want to check this palette on Moonriver, for example. That's how it is on Moonriver. On Karura, for example, is I want to go to Karura and I want to find this general index or this general key specific, because that's how Karura sees its own token. So it is still very complex because there is no standard, to say, okay, all the parachains will see their own token this way. And this actually gives a lot of flexibility for parachains to play around. But yeah, in the case of Moonriver, I think this event that Scott was talking about was Moonriver because he's talking about other reserve, and that's something particular of Moonriver.
Yeah.
Just if I'm not wrong, Alberto, that link I put in from Polkadot.js, where you list out the different asset IDs, is that the currency? That's the currency ID, right?
Yeah, exactly. So if you put the other reserve that Scott is showing on the slide, you will see that you have the asset ID. For example, the one that starts with a 10 for Karura, the ones that start 42 for XCM, and so on and so on, right? And actually, this asset ID or currency ID is used to calculate the XC20 address for the EVM, right? So what you do actually is that you grab that number, you transform it to hex, and then you prepend 8 Fs just to make sure that it has the same length as an Ethereum address. And there you go. You have the XC20 address. And you can do all that here, right? I mean, you can manipulate the data as you want with SubQuery and then store it as you want, right? I mean, if you're crazy enough, I guess you can just go ahead and grab the currency ID and multiply it by 2, right? If you want that, I guess. So you can handle the data as you want. That's really cool.
Yeah, we're very flexible what happens within this event handler. If you run it in the unsafe mode, you can do whatever you want. You can retrieve data from different resources. You can throw anything in there.
I love the name of the unsafe mode, right? I mean, everything here is so cutting edge that it's pretty like unsafe.
Well, that's a key note to probably share with the community. So SubQuery by default runs in a safe mode, and one of the key design considerations of SubQuery is for it to run in a deterministic way. A deterministic way means that if Alberto runs it and Alberto is on the other side of the board from me, we'll get the same data always, every time. So unsafe mode allows you to do external requests and bring in external libraries, because as soon as you bring those in, we can't guarantee that determinism. So anytime you want to use these external libraries, you have to run an unsafe mode, which is fine. Just be careful what you do, because if you're making a request for a foreign thing on the internet, you don't know if that changes. You never know.
Awesome. And I want to go back once again to the handle call function that you have there, Scott. So that is how you would actually because we discussed that unluckily, the events are not enough, right? The events are not enough to actually, if you want to try the XCM Explorer, you want to start building it. The current state that we have right now is not enough to be able to map an XCM from Moonriver on Kusama, right? So one of the things that we actually learned yesterday was that you can actually leverage extrinsics, the XCM extrinsics, to try to build a little bit more data around this sort of things. So that is what you do on line 20, right? Even though it's commented, that is like what you need to call, what you need to do to handle extrinsics, and then you also grab the extrinsics data and then record it however you want.
Yeah, exactly. But like on the other side of that is that you can get the extrinsic for an event. So if you have an event handler, it's not guaranteed to have an extrinsic associated with it. But in this case, you're very likely to have like on the receiving chain. I don't think there's a matching extrinsic. You just get events out of it, and it's run by the chain.
You get a transfer extrinsic, which includes that X token. Let me just remind myself what it is.
Yeah, exactly. So I mean, for example, in when you send a message from Kusama to Moonriver on the target chain on Moonriver, you will have an extrinsic associated to all the events that are XCM related, which is what I put on the slides, and we'll share these slides in a moment. But yeah, it's really cool that you can do this on the same handle event function. I think this will be really useful, and I even think that people won't really need to use the handle call, because if you can access the extrinsic and all this data from the handle event function, that is basically sufficient, I would say.
Yeah, and having access to the extrinsic, you can get all the other events related to that extrinsic. You can even get the whole block if you wanted to see other extrinsics within that block for reference. So yeah, it's pretty powerful. You should be able to get all the data you need through these event handlers. Yeah,
and we can just quickly show how this looks on like Subscan, for example, where if I just share my screen, we have. So this is an event, for example, where there's an X token transfer.
Oh wait, I think Scott has to stop sharing his really quickly. There you go.
Right.
Can you like reshare your screen, James? Because now we have this weird situation. All right.
Let's try again. Can you see that now?
Yep, perfect.
Yeah, so this is a Ethereum transact extrinsic, but includes many events, one of which is the X token transfer event, which we are subscribing to in that SubQuery project. And the data on this payload is what Scott has shown you being mapped in that handler, right?
Actually, really cool that you brought this up. Can you actually zoom a little bit and also expand the event just above that X token one, the XCMQ event? So that right there is the message hash. So the cool thing is that if you go to the destination chain, you will also see another XCMQ message, and there will be also a hash. Let's wait a little bit. It's on there you go. Those hashes should match. And the cool thing about that is that it's a really easy way to match. Okay, this XCM from Moonriver was executed successfully in this other parachain. Yeah. So it's actually really cool that you brought this up, James.
Because this is Moonriver, and then this is Consumi. So this is a X token transfer from Moonriver of 2068 Kent tokens. And here we get the receiving of that. We receive that here. But actually, what's another interesting thing is it doesn't actually kind of show up in a transfer event for another couple of blocks. So actually in about 6 blocks, it's actually 5 blocks later. So this is block 48, and this is block 43. And block 48, we get a tokens transfer, which actually matches the. So that destination is the actual the account ID here, I believe. No, the account ID here. I want to share how we kind of convert that account ID across.
Yeah, I can actually put some steps, but you have to go to. There is actually a really cool tool called Sean Tribisi JavaScript Utilities. So I'm going to share that link here. Sean, this tool is like one of the tools that I always have in my bookmark. I shared it in the channel here in the chat. You can actually, if you visit that, you would have to know as well what metadata a Kintsugi uses, right? So you can actually decode. So this is actually how substrate addresses are represented in hexadecimal. They're encoded in a way so that you have like a nicer and prettier number out there. So, but basically, this is how in an XCM message, how the destination address is basically represented. But we can add that on the slide. So, yeah.
And also something to make life a bit easier. So you might wonder, like, okay, well, how do I correlate this XCMPQ success extrinsic or event specifically, to that random token transfer. And it's not easy. Usually it's like between 3 to 8 blocks behind. But this transfer event is always from the sovereign account. This sender account is a sovereign account of Moonriver on Consingbee. And as I've said, you've got a tool to allow you to generate and find out exactly what sovereign account. So any transfers from this account, you can be extremely confident that those are cross-chain transfers. And you can see here that the amounts, 206.8 kint, matches what we had on this side, right? 206.8.
Yeah, exactly. So, I mean, we never say it was going to be easy. We didn't say that at any point of the presentation that doing the XCM Explorer was going to be easy. But I think you have to consider that this is, once again, like I said, bleeding edge stuff, and we're actually learning as we go as well. We are actually very excited if someone takes on this bounty, because this is something that is going to be super useful for the entire ecosystem, not Moonriver, not Kusama, but the entire ecosystem. And if you actually build this XCM Explorer in a generic way, it would be really easy to implement in Polkadot. It would be really easy to onboard any parachain that you want once they have XCM capabilities. So, I would say it's challenging, but it's definitely fun. And, there's no better thing to code about that. It's, this challenging stuff that it's not straightforward. So, yeah. And I think, we do believe that, SubQuery can play a pivotal role here because, indexing all these events and data, it's a must if you want to have a performant explorer for sure.
Yeah, and again, XCM transfers are going to be the future of Polkadot, right? The whole point of Polkadot is this ease of cross-chain communication. And so building a solution for this kind of stuff is going to be a key part of that.
Definitely. All right, I think we can wrap up. Thanks a lot, James and Scott. And yeah, we added this slide at the end, so you can actually check. This is I'm going to share the link now before I forget. This is how you can get started. Some related content that we have here. So you have the Moon Builders workshop around XCM, where you can learn a little bit more about XCMs there. We have the ETH Denver XCM presentation, which is a little bit high level, but also helpful in case you want that. We have the docs.moonbeam.network, where you have a lot of content in there of XCM, XC20s, how you get started on Moonbeam. And then also they added an example SubQuery project in case you want to use SubQuery, which definitely I think it's a recommendation to start building these XCM Explorer. In case you want to get in contact with us, we have our Discord Moonbeam channel. We have a Hackathon channel, sub channel inside our Moonbeam Discord. We also have a specific Telegram in case you want to ask any questions there, called Moonriver Grant, and also the SubQuery Discord in case you want to go in there and ask any questions directly to James or Scott. I want to thanks once again, James and Scott from SubQuery, to join us today in this workshop. And we are definitely excited to see some submissions around this XCM Explorer. And hit us if you have any questions. So thanks a lot for tuning in, and have a great day, afternoon, night, wherever you are in the world.
Yeah, we're more than happy to help. And thanks for everything, Alberto. Thanks for all the research into this. Not a simple thing.
No, not at all. All right. Thank you guys. Have a nice day. Cheers. Bye.